topic with me. In this video, I want to learn you one of the apart mathematics is surds. If we talk about surds, we talk about addition, multiplication, subtraction, and division surds. However, I will learn you how can anyone to differentiate between simplify and irrational and rationalize surds, and I want to explain you the definition of surds. In the last video, I wish you all get more benefit with my video knowledge after see my video, and don't afraid to learn mathematics, to growing up you're interested about mathematics, because learn mathematics to be fun. Trust me. See you soon. We start with surds. The roots of some number produce rational answer. For example, the square root of 16 equals 4, the cube root of 27 equals 3, and then the square root of 4/9 equals 2/3. The last, if the square root of x cannot be simplified further, then it is basic form. The square root of 17 and the square root of 43 cannot be simplified further, because 17 and 43 are prime numbers. Example prime numbers, which is 331, maybe 2, if roots cannot be written as rational numbers, surds are therefore irrational numbers. Example of surds: the square root of 2, the square root of 3, and the square root of 10. Using a calculator to calculate a decimal equivalent is only an approximation. The answer is the square root of 2 equals 1.4142. The square root of 3 equals 1.732. The square root of 10 equals 3.162. Simplification of surds. The definition is the square root of some numbers which are not prime, such as the square root of 20, the square root of 63, and the square root of 363 can be simplified. The square root of 20 equals the square root of 4 times 5 equals the square root of 4 times the square root of 5 equals 2 the square root of 5. The second example, the square root of 63 equals the square root of 9 times 7 equals the square root of 9 times the square root of 7 equals 3 the square root of 7. Next, the square root of 363 equals the square root of 121 times 3 equals the square root of 121 times the square root of 3 equals 11 the square root of 3. The next, This is a rule of simplification Surds. First point is the square root of a times the square root of a equals a. Example, the square root of 3 times the square root of 3 equals 3. Second point, the square root of a times the square root of b equals the square root of ab. Example, the square root of 4 times the square root of 5 equals the square root of 20. So, 20 come from 4 times 5. Third point, the square root of a divided by the square root of b equals the square root of a divided b. Example, the square root of 10 over the square root of 2 equals the square root of 10 over 2 equals the square root of 5. Fourth point, a the square root of b times the square root of c equals a the square root of bc. Example, 2 the square root of 6 times the square root of 3 equals 2 the square root of 18. Fifth point, the square root of a plus the square root of b not equals the square root of a plus b. Example, the square root of 5 plus the square root of 8 not equals the square root of 13, as 5 plus 8 unequals the square root of 13. We cannot calculate the square root of a plus the square root of b because they are not same. Basic on the Surds. And the next, we simplify this question. The square root of 3 plus the square root of 12. In order to add Surds, they must both be multiples of the same Surds. The square root of 12 equals the square root of 4 times the square root of 3 equals to the square root of 3. Therefore, the square root of 3 plus the square root of 12 can be written as the square root of 3 plus 2 the square root of 3 equals 3 the square root of 3. How about 4 the square of 5 plus 7 the square root of 5? Let's see the square roots of 5. There are same base of the root square equals the square roots of 5. Calculate the numbers are not Surds. 4 the square roots of 5 times 7 the square root of 5 equals, we can calculate 4 with 7. 4 plus 7 on the out bracket, the square roots of 5 equals 11 the square root of 5. This is expand and simplify that form. On the bracket, a plus the square root of b times a minus the square root of b. On the example, 2 plus the square root of 3 times 3 minus the square root of 3, multiplying both terms in the first bracket by both terms in the second bracket gives 2 times 3 minus 2 the square root of 3 plus 3 the square root of 3 minus the square root of 3 times the square root of 3 equals, we calculate 2 times 3 equals 6, and we add plus the square root of 3 minus 3 equals 3 plus the square root of 3. Okay, the next. This is rationalizing fraction with surds in the denominator. That from example 1 over the square root of 12 is a fraction with a surds in the denominator. It is considered mathematically more elegant if fractions are written without surds in their denominator. So, 1 over the square root of 12 is not elegant. Removing surds from the denominator of a fraction is known as rationalizing the denominator. To rationalize, the fraction must be multiplied by a fraction that is equivalent to 1 but which eliminates the surd. So, we must eliminate the square roots of 12. This is explained. The question rationalize 1 over the square root of 12. Give the square root of 12 over the square root of 12 times with over 1 over the square root of 12. Calculate can be the square root of 12 over 2. So, the square root of 12 over the square root of 12 is 1. So, therefore, is unchanged when multiplied by 1. In general, to rationalize a fraction of the form a over the square root of b, multiply by the square root of b over the square root of b to give the square root of b over the square root of b. This is another question if the denominator not single. Example, in this case, turn multiplying by 3 plus the square root of 2 over 2 plus the square root of 2. As this will not eliminate the surds in the denominator, is that form multiplying by 3 plus the square root of 3 over 3 plus the square root of 2 can be that form. So, to rationalize this type of fraction requires an understanding of the difference of two squares that a minus b, a plus b equals a square minus b square. This demonstrates that if either a or b are surds, the result involving a square and b square will be rational. Therefore, to rationalize 1 over 3 plus the square root of 2, we can be give multiply by 3 minus the square root of 2 over this 3 minus the square root of 3 equals 1 times 3 times 3 is 9. 3 times the square root of 3, the square root of 3 times the square root of 3, and then the square root of 3 times 3, and we get the last answer 3 minus the square root of 2 over 7.